As we go on to Module 5, we're going to take a look at Section 1, the exercise set. And I believe we'll have everybody work on examples 1 through 10, where for 1 through 6, it is to complete each of the following to form a true statement. And then here we're looking at the equations, and even though they're not in standard form, they want you to find the zeros. So being able to pick them from a graph is one of the techniques we went over in class. So let's pause, and I'll see if I can make this a little bigger. And there we go. And to start you off, I'll do one with you. The principle of square roots states that when you have something like this, you take the square root of this side, that will give you an x, and then you take plus or minus the square root of the other side. So for this one, it will be the plus the square root of k, and this one is going to be minus the square root of k. So give these your best shot based on what we've been doing, and we'll pause it at this time. Some of these were a little challenging. First of all, to figure out what they wanted. We did number 1. Now in number 2, in using the principle of square root, we take the square root of a perfect square. That just becomes the radicand. And then take plus or minus the square root of 49, which gives us a plus 7 and a minus 7. So the principal square root of 49 is 7, and then the opposite, which is our negative value of that square root, is a negative 7. So that's what they wanted there. Now in number 3, as we look at it, this is a perfect square trinomial that will factor into t plus 3, the quantity squared. So then we take the square root of that, and that just leaves us the radicand, and then plus or minus the square root of the other side, which is plus or minus 17. In number 4, again, this is part of our perfect square trinomial. We had to find out what is our c term here, and we said it's half of 8, which is 4, that we squared to give us 16. Now, in order to get this equivalent to this, what we'd have to do is what would have been on this other side here, so that eventually this becomes a 23. Well, the answer is it would have been a 7, to which we add, to keep this an equation, we add the 16. Once we put a 16 there and a 16 there, that makes it a perfect square trinomial that now this side becomes a 23. So this one's a little tricky. Number 5. Here they're just asking us to complete the square. we take half of our b term, which is 5, and square it. And then our perfect square, or our binomial that we're going to square, is this. And this is just another exercise where we look at our b term, which is negative 3. Half of that is 3. I'm sorry, negative 6. Half of that is 3. Squaring 3, we get a 9. So this is our binomial that we square. And remember that little technique, we just put that there. We take our x, put it there, put this sign there, and take half of that, a 3. And then we square that 3 to get our c term, and there it is. So a little bit of a review to what we're doing. We went a little further, of course, in our lesson. Now, for this part, what they're asking us is, just by looking at the graph, how many solutions would we have? Well, it's, in a sense, finding the zeros, and we're looking for where the graph actually crosses the x-axis. Crosses the x-axis at these places. So, this then results in our having 2 real solutions. Now in this case, as we look at this particular equation, and this is the graph of it, it doesn't reach the x-axis at all. So it is a graph, but there are no real solutions because it never reaches the x-axis. So we can't find any zeros. There are none. In number 9, we see a parabola coming up from the bottom, and it's just touching the line in one place. So there is one solution. And then here we see there's one there and one there. Now if we could actually read these values, they would be the solutions for these equations. And that will wrap this up. You'll have your practice in QuizMes.